Okay. What's another disadvantage of STP? Let's say this topology is here. Now our company is bigger than before, and we have a different layer switch, access layer, distribution layer, and about distribution layer between different devices, we connect with multiple links. In this scenario, we want to get higher bandwidth and also can provide redundancy backup. How to solve this problem? Because maybe about this part, we can use the STP to avoid the loop, right? But between the switch 3 and the switch 6, we have 3 links. If we use the STP, at least 2 interfaces will be blocked. Otherwise, there is a loop, right? If one interface we have 1 gigabit bandwidth, that means totally 3 gigabits, we only can use 1 in the same time. If one link is broken, we can use the second one. But if we want to use the totally bandwidth, how to solve this problem, how to meet this requirement, we can use link aggregation, right? What's the function of link aggregation? The link aggregation means we can use the physical link to become a logical link, right? And about the customer, they will think I only use 1 link to follow the traffic, but the total bandwidth is 3 gigabit. So this is the advantage of link aggregation. And about the link aggregation, we have to select who is the port aggregation. Is this one, port aggregation. And how to add the configuration of link aggregation, we have 2 types. One is static and another one is dynamic. But both of them, we have the advantage. We can extend the link bandwidth. For example, totally 3 gigabits can be used. We also can use the traffic balance. That means all the links can follow the traffic at the same time. And we also can provide the automatic link redundancy backup. So this is a good advantage of the link aggregation. And how to make the configuration? We say we have 2 modes. The first one is static aggregation. The second one is dynamic. Static means both sides we have to add into the aggregation port manually, and they will not exchange any information with the other side. But dynamic aggregation means we will use a protocol, we call it LACP, and both of the switch, we have to send out the LACP packets and to negotiate some parameters to select and decide which interface can work, which interface cannot work, maybe finally cannot be selected. So this is a dynamic. And both layer 2 and layer 3 ports of the switch support the port aggregation, both the static and the dynamic. And about the detail, how to select who is the AP and how to select who can make the link aggregation member and finally to follow the traffic. The detail you also can see maybe on the RCNA certification course. But here I will explain the detail one. We say link aggregation can provide the traffic balance, right? Besides on different parameters, we can according to the MAC address information, IP address information, and both the MAC address and IP address together. Something like this. Finally, to decide which interface, which packets can use which link to follow the traffic. And how to select this one, or how to check what's the balance mode, we can use a command, show aggregate port load balance. For example, about this switch, the load balance mode is source IP and destination IP together. That means the traffic with the same source IP and destination IP, they will use the same link to forward to the destination. So this is the load balance. And the main configuration, this one is too long. Okay. The configuration of static aggregation, we have layer 2 and layer 3. About the layer 2, we can enter the interface and then to set the aggregation port number to become 1. Of course, if the link aggregation port number 1 is not exist, this command will be created automatically. And then we can enter the aggregate port 1 to directly change the mode to become chunk. That means the physical interface 1, 2, 3, both of them will use some VLAN mode to become chunk. And then we can decide the aggregation port, the load balance depends on the source and the destination IP address. So there is a layer 2 configuration. About the layer 3 configuration, we can create the aggregation port at first. And the no switch port means we make the interface to become layer 3 interface. By default, there is a layer 2 interface. About layer 3 interface, we can add the IP address. And then about the physical interface, we also have to change the mode to become layer 3 and add into the aggregation port. And finally, in the global, we can decide the load balance besides on the source or destination MAC address. So this is a configuration of the layer 2 and the layer 3. But by default, the aggregation is static. And about the dynamic difference one is between switches, we have to send out the aggregation packets, the LACP packets, and then they have to do the negotiation. The configuration is very similar with the static one, but the difference is like this. Enter the interface. We also add the interface into the link aggregation part, but we have to change the mode to become active. If we don't add this command, the default mode is static. If you configure the one site to become active, the other site also should be active. If one site is static, the other site also should be static. The other configuration are same with static. We also have to add the physical interface into the logic, into the link aggregation port. And about layer 3, we can add the IP address. And we have to change the layer 2, the mode to become layer 3, interface. And the layer 3 aggregation, we also have to change the mode to become active. That means we will use the LACP. So this is a link aggregation configuration. And later we can check show aggregation port and what's the port number, what's the maximal port number, what's the import mode, and now is access, and what's the physical interface. About the link aggregation, we have the limit of maximal number. Pay attention about this one. For example, here is 8 ports. Someone say I want to use 100 gigabit, so I use 100 link. It cannot work. Okay, we have the limit of the port, 8 ports. So this is a link aggregation. Now it's clear for you about this part. So we talk some technology about the switch, right? Switch, how to work, and how to learn MAC address, and how to forward the packets according to the information, according to the MAC address. Oh, thank you, very clear. Yes. Oh, the first question, the answer is A. Okay. And besides the switch, we also explain something about the VLAN, right? Use the VLAN, we can limit the broadcast domain. But if we want to avoid the single failure, we can add more devices and more link on our network. But we have to avoid the loop. So we use one protocol is STP. Of course, pay attention. STP is not only solution. We also have another solution to avoid the loop and also provide the load balance. Also provides the backup function like the link aggregation mode, like the VSU, like say other technologies. But today I only explain two backup solution. One is STP and another one is link aggregation. So here is a very useful and basic function of layer 2 switch. Okay, the main principal technology. If you are clear, maybe we have to talk about the next part, about the DHCP. DHCP also is very useful because about today's training, we explain two PC directly connect with each other, and then they can use a cable to forward. If the network to become complex, we use VLAN, we use STP, we use link aggregation. But what is the function of DHCP? Actually, you can think this is a technology used for the terminal. Because all the devices, yes, automatically provide the IP. Because all the devices like the terminal, our PC, our client, they must have the IP address and then they can work, right? And of course, they need to have the MAC address. But by default, all the network card already gets the MAC address before. But how to assign the IP address for the client? One way we can use a static way, right? That means everyone configures the IP address manually and to give the IP address. The second one, we can assign the IP address, yes, static. And the second one, we can use the DHCP server to assign the IP address. Because about the DHCP server, to assign the IP address, there's some advantage. Of course, have some disadvantage. For example, if now we choose a manual way to give IP address, subnet mask, yes, and the gateway and the DNS manually. So this is a configuration of the manual way, step by step. But in our network, not everyone know what means IP address. I think today everyone know what means IP address, right? But I also know IP address, but my family, they don't know what means IP address. So maybe they don't know why the number should be 192.168.1.1. They will give a wrong IP address. So if we give the wrong IP address, there's some disadvantage. Although everyone know how to make the configuration of a static way, but the mentors, for example, our Ruijie engineer, and also show you a table. Your laptop should use this IP address, but the other laptop should use other IP address. But no one maybe care about this one. I will give the wrong IP address. Then there is a conflict. Or maybe they give us different segment of IP. They cannot visit the internet, right? But all the terminal, if I cannot visit the internet, I only have one solution, found my engineer. I will call my engineer, come on to solve this problem immediately. And you maybe ask what's the IP address. The terminal maybe say, I don't know what means IP address. So in this scenario, typical, maybe our terminal is very, in our network, there are many terminals. We hope we can have one solution. Reduce the difficulty for users to configure IP address. Because about manually way, you have to create so many parameters, right? And we also want to reduce the workload of the network center staff. For example, if you manually, maybe there's some conflict. And we also hope there is a way to avoid the IP address conflict because of the misconfiguration. So in this scenario, maybe we can use the DHCP. Yes. And about the DHCP, we have the CS architecture. So in this scenario, we have one device to become DHCP server. S means server, C means client. And the client may be your laptop, maybe your PC, maybe your phone. This one we call is DHCP client. And the client will ask for the server to help. I want to get IP address. Can you help me? Something like this. So between the client and the server, we will use the DHCP protocol to ask, I want an IP address, and give a reply which IP address you can use. something like this. And the configuration on the server, we have to enable the DHCP server at first. Then we have to configure an address pool and the IP DHCP and the pool name, Ruijie. You can use other name like test, like 123. They also can work. And in this pool, which segment IP address can be assigned? This is a network IP address, and the default route ID is a gateway, and who is a DNS server. Then about your client, you only need to select the IP assignment to become DHCP. Oh, it's similar to Cisco. Yes. Every command is similar. And also about the DNS, you have to select automatically about the DHCP. It's enough for clients, right? And later, we enter the DOS to check your IP address is enough. Of course, between your client and the server, if you use a layer 2, the broadcast domain have to be the same. Otherwise, the DHCP packets cannot send to the server. I cannot get the reply. So about the client, it's very easy to finish the configuration. Yes. And the main process about the client, I will send out the DHCP Discover. This packet is used. Is there some DHCP server or not? Of course, when your client, if you select automatic or select DHCP, they will send out the DHCP Discover packets automatically. We don't have to do any configuration of the client. And then the server will give a reply, DHCP offer. That means I can have the ability, I can have the function to assign the IP address. Then the PC will give a request. Please help me. I want to get an IP address and the mask and the gateway and the DNS, and later I can reach the internet. So the server will give a check acknowledgement. So these are the main parts on the DHCP. Includes 4 packets. So after we exchange these packets, later we can get the IP address. So PC can use this IP address to visit some destination. Of course, if you have the tool to get the packets like the Wireshark, you can get this information. Okay, the configuration is very easy about the DHCP server. You only to assign the IP address is enough to assign the IP pool. It's easy, right? So this is a DHCP, especially in our network. Maybe your office, maybe your hotel, maybe some other scenario. Your terminal is so many, and they want to get IP address. In this solution, maybe you can use the DHCP to assign IP address for the client. And another scenario, if in our network we deploy the wireless network, our terminal maybe is our PC, maybe is our phone, also have to get an IP address. And in different time, maybe we access in our network, the time is different. So in this scenario, we often use the DHCP to assign the IP address.